Howdy! In today's video, we're going to look at absolute value of numbers and how to calculate the distance between two real numbers. So we're going to start with basic concept of absolute value. The absolute value of the number 3 is just 3, and that is because the distance between the number 3 over here and 0 on that number line, that distance is 3. If you count 3 to the right of 0. Now, the absolute value of -3 is also 3 because the number -3 is also a distance of 3 units from 0. So one way to think about absolute value is that it just makes all numbers positive. If you want to find the absolute value of a more complex expression, such as the absolute value of 1 minus 7, that's equivalent to the absolute value of -6 or +6. Okay, this one is an absolute value inside of an absolute value, just to see if you know what you're doing here, right? The absolute value of 4 minus the absolute value of -15. We're going to work our way from the inside out because of order of operations. So that absolute value of -15 will become +15. So I'm going to rewrite this whole expression one step at a time as absolute value of 4 minus +15. Next, we do the subtraction. We do not take the absolute value of each number and then subtract. We do the absolute value of the whole expression. So 4 minus 15 is -11, and the absolute value of -11 is 11. All right, we can use absolute value for a number of different things, but one of those uses is to find distance between 2 points on a number line. So if A and B are real numbers, then the distance between those 2 points, A and B, on the real number line is the magnitude or absolute value of their difference, B minus A. You could also put A minus B. You'll get the same answer. It doesn't matter, right? But it's the absolute value of their distance, of the difference between them, right? So if A is here, B is here, subtract those two numbers and find the difference. Now, it does not matter if one of those numbers is negative or if they're both positive or both negative. You just follow this rule and you'll get it correct every time. That's a nice thing about how negative numbers work out, right? So let's try this example here, which I've got drawn. Find the distance between 2 and -8. Now we're going to do this 2 different ways, actually 3, because the first way we're going to do it is just by counting. Everybody can count, right? So we start at -8. Well, if I count how many units it takes to get to 2, we're finding distance. There's 1, 2, 3, 4, 5, 6, 7, 8 to get to 0, and then 2 more. So that's a total distance of 10. Now let's see what happens if we take the absolute value of let's do 2 minus -8 first, and then we will reverse it also. So 2 minus -8, that's equivalent to 2 plus 8, which is 10, and the absolute value of 10 is 10. There's our answer, right? But if we reverse it and we put the -8 first, and we did -8 minus 2, so kind of absolute value of A minus B, right? We will get the same thing because -8 minus 2 is -10, and the absolute value of -10 is also 10. So no matter how you do it, the distance between two numbers is given by the absolute value of their difference. And last, let's do one with fractions just to make this interesting, right? So we're going to find the distance between -2/21 and 9/14. And let's practice our skills because we want to do this without a calculator. Let's just assume that, right? So to find the distance between them, now this one I'm only going to do it in one way. I'll assume this one's first number's A, second number's B. So if I do absolute value of 9/14 minus -2/21. Okay. Well, minus the negative does become positive. All right, so it's absolute value of 9/14 plus 2/21. And then to subtract or add fractions, we need a common denominator. And I don't want to just multiply them together because that's going to be kind of hard without a calculator. 21 times 14, there's room for error. Let's consider the fact that they both already have a common factor of 7, right? So let's just make a little side note here, right? 14 is equal to 7 times 2. Well, 21 is equal to 7 times 3. So all we really need to do is multiply the first fraction, which is 9/14. I just need to multiply that by the missing, let's fix my little 4 there. There we go. The missing factor of 3, because this denominator has a 3 in it. So times 3/3. And then the second fraction is 2/21. We're going to multiply that. Well, that 21 already has a 7 and a 3. It's missing the 2. So we're going to multiply that by 2/2. doing this way is really a preparation for how you're going to get a common denominator when you deal with rational expressions, right? All right, I'm going to bring that down to the next line down here. And so multiplying those numerators to multiply fractions, we get 27 over 14 times 3. Now you may have to do some scratch work, right? But actually, I think we can do this in our head because 10 times 3 is 30 and 4 times 3 is 12. So that would be 42 plus, we have 2 times 2 or 4 over 21 times 2 is also 42. Now we have a common denominator, so we can add those two fractions. We do so by adding the numerators. 27 plus 4 makes 31 over 42. And it is positive, so we can just drop those absolute value bars, and we get 31 over 42 is the distance between those two fractions.